Welcome to NX for Manufacturing Tech Tips. Today's tech tip is an introduction to feature-based machining in NX. Demonstration will last approximately 20 minutes, and we'll stay on the line and open up the chat window for questions and answers. With that, I'll turn the session over to Tom Van Erve. Welcome, Tom. Let's get started.
Thank you, Derek. Welcome, everybody. It's my pleasure to try and introduce to you NX CAM feature-based machining from a user point of view. This session we will look at how to use feature-based machining, and in the next two sessions we'll drill down deeper into how to customize and configure the feature-based machining system. Before I get started, 2 or 3 slides to give you a very quick introduction. I think most of you will be familiar with the traditional, I call it manual, ANSI programming steps in just about any CAM system. You start with defining your setup or your workpiece. You position the workpiece on your machine. You define your clamps, your fixtures. You start creating operations, and for each operation, whether it's a drilling operation or a milling operation, you select a tool, you select the geometry, you specify the operation parameters, the depth of cut, the step over, the engage and retract motions. You do a generate of your tool path. You look and try to see if it does what you expect it to do. You might define feeds and speeds, add user-defined events, and you're probably going to have to do a couple of iterations before you get it right. And once you've done one operation, you continue with the next. And finally, when you're finished, when you're happy, you post-process and simulate, or you simulate and then post-process depending on the capabilities of your system. Compare that to feature-based manufacturing. The steps are not all that different. You still start with defining your workpiece, your setup, but then instead of manually defining your operations, you perform 2 steps. You automatically find your features, and you let the software automatically suggest your operations. Then you generate the tool paths, and if necessary, you start making some changes to the automatic suggestions. You change operations, you add some new ones, you delete them. What feature-based does is generate normal operations as if you had created them manually, but it does that automatically. And to finish it off, you have an NC program that you simulate, verify, and post. Traditionally, feature-based machining has been used predominantly in hole making and 2.5D milling. The industry doesn't matter that much. It could be mold bases, could be machinery parts, could be automotive parts, could be aerospace. Just about everybody drills holes. So that has been the traditional area where CAM automation, feature-based machining has been used. Within NX CAM, the scope is actually a lot bigger. We're able to do turning, especially grooves, wire EDM, thread milling, hole milling, planar milling, cavity milling, all the fixed and variable axis, Z-level, and surface contouring operations. Almost everything you can program in NX, we can also create automatically for you using feature-based. There are still a few limitations, but we're working hard to get those off the table as well. For the demo today, as I mentioned, I'll focus on a simple part to show you the concepts, show you how it works. I'll do 3 demos, one after the other. I'll start with the part that you see on the screen, focusing on simple milling and drilling operations. I'll do a wire EDM example, and I'll show you what you can do using geometry that was not modeled in NX. So I'll do something on a step file. I've already defined my part setup. So I have a workpiece defined. Within the workpiece, I have defined my finished part. I have defined a blank. Maybe hard to see, but it's a casted blank, so there's some offset material on some areas of the part. I've defined my fixtures. I've defined my part material. That's my start situation. If we look at the NX Operation Navigator, you see that I have prepared some MCSs because I'm going to machine this part from various sides, and I want to have an MCS predefined for each of those sites that I'm going to machine. In my program order view, I have no operations whatsoever. In my machine tool view, I have no tools, and that's my start situation. So now let's get started with feature-based machining. I'm switching from the operation navigator to my machining feature navigator as a first step, and I'm now actually going to perform the two feature-based steps to get an automatic programming for this part. I'm starting with my find features command. I have that pre-configured to use parametric recognition. I'm looking at my entire workpiece, and this is a list of feature types that come with NXCAM out of the box, and I've selected a few of them. And normally I would just run across the entire part, but in this case I'm going to not run my recognition on the entire part. I'm going to use a color filter, and I'm basically going to select all the faces of the part that my design department has indicated with a special color that need to be machined. And I'm going to run my recognition on just those 100+ faces. This is where the software is analyzing all the various geometry in the part, and it's coming up with manufacturing features. It's an automatic step, and we're basically finding manufacturing features. And if I show you the details of those manufacturing features, you will see that there are different types. So each entry in the list is a feature. The first one is a rectangular pocket, and it comes with a set of predefined attributes like a length, depth, width, and a corner radius, but it also has a bottom roughness and other attributes that, and a side roughness, other attributes that I need to be able to select the right operations and right tools. So quickly browsing through the various features that have been identified, you'll see some through holes, some threaded holes. This was an NX part, and the design department will already put thread on my geometry. So I have some threaded holes. I have some more complex holes with 2 diameters, and I have a few other complex holes with even 2 and 3 diameters. That's basically the first step, running feature recognition and getting a list of features that have been found, each with their type, with their attributes, and other information. The next step that I would now do is select all those features and ask the system to create operations for them. So what we're doing is we're using the rule-based method for getting feature-based operations. Looking at my library of machining knowledge, I'm looking at my drill mill methods. Everything else is automatic, and I'm asking the system to go make a suggestion for the operations for this part. The information window is just nice if you're a developer like myself, or you're configuring the rules and you want to see what's happening. This process for 40 features maybe takes 50-60 seconds, so it's good to see something moving, but normally end users don't even see that. They click the button, wait 30 seconds, wait 2 minutes, depending on the complexity of the part, the number of features, and they get a result. Obviously, in the next 2 tech tip sessions on this topic, we'll look at how I can configure what's happening behind the scenes here. Now we'll just look at what comes with NX out of the box. So anybody running NX, the latest version, can do this on their parts, and it will come up with some tools and some operations for your features. You might not like it, it might not be perfect, but it will do a lot of the operations automatically for you. We're done. I'm removing my information window. Let's go back to the operation navigator, and now you'll see that a lot of objects have been created. These are called feature groups, and if I switch on my see-through, then we can easily see the areas that have been grouped. So my pocket and my partial slot have been grouped. And here I have two different groups with a single hole. I'll explain in a minute how those were done. Those three features were grouped together in a single set of operations. Those were grouped. Those four were grouped. And each feature group, as we will open it up, will have the same set of operations. So all those four features in this group will be spot drilled, drilled, and tapped. And we can look at the rest of them and see what the software grouped. Then obviously in the other MCSs, I'll see feature groups from other directions. The most complex one is a 3-diameter hole with 5 operations that need to be selected, need to be performed on such a complex hole. Now let's look at the results in a little bit more detail. Underneath the feature group, I basically get 2 general CAM operations, a roughing for my pocket and a floor finishing. If I look at the slot partial, I get a slotting operation. So normally the next thing I would do is just generate the tool paths. And I won't do them for all, but I'll take a big group and quickly generate the tool paths, and we'll look at the different results. The key thing to remember here is that you did not create these operations manually. We created them for you, but they're still regular NX CAM operations. The standard operation types that you know as a CAM user, selected tools from the library, specified depth of cut, specified step over, and as soon as the operations have been generated, we'll look at how we can change some of that. So let's look at maybe this first operation. I'll zoom in a little bit. That area is a milling operation, and the system basically knew what my it's a floor wall operation, a new NX5 floor wall operation, so it knows what my my floor is, what my walls are, and it basically selected a follow part operation with a certain step over and depth of cut, and that's the tool path that we just generated. And just to show you that it's a normal operation, I can now go in and specify that I don't want 75% step over, but I want to have 20% step over. Regenerate the tool path, and I'll have a different different result, as you see, right? Or I want to have some more axial cuts, changing the depth of cut, anything just to show you that this is a regular operation. Maybe it doesn't make too much sense to do it with such a small depth of cut, but maybe this is a complex material to cut, and it's a regular operation, so I could do a simulation or verify 2D, if you will, to just show you that, hey, it's a normal operation, right? It's a floor wall operation, so it's only cutting where there's material. It didn't do any air cutting above the floor, and we're done, right? So zooming back out, this is showing you it's an automatically generated operation. I can now go in and change it. I can delete it. I can use a different tool, but based on my best practice that we've configured, this would be the best way to do it, and it's extremely fast getting it that way. What I would like to show you briefly is the difference between these two holes, because they're geometrically the same. They have the same depth, they have the same diameter, and still you will see different operations. This one is just spot drilled and drilled, and that one requires spot drilling, drilling, and reaming. Why is that? That's basically because of what we call PMI, Product Manufacturing Information. The designer put an H7 tolerance, a diameter tolerance, on that feature. So if I go back to my objects, find related features, to my feature, look at the details, then this actually has a diameter tolerance. The diameter is 11 mil, but it has a lower tolerance of 0 and an upper tolerance of 18 thousandths of a millimeter, so it's a very accurate hole. If we look at the other one, that is probably that one, it doesn't have that tolerance, same diameter, but plus minus 0.2, obviously resulting in completely different operations. The plus minus 0.2, we just spot drill and drill it. The highly toleranced hole requires different operations. And in this case, it requires a reaming operation. So feature-based can look at not just the geometry, but at the PMI as well. Let me continue and make one change to show you the impact of PMI. So I have PMI defined, and one of the PMIs that I have defined is the surface finish here, a 3.2 roughness on the bottom of the pocket. If I would delete that, go back to my features, I would now actually see that my feature has a different status. It's modified because there was a surface roughness at the bottom first, and now it's not there anymore. I can approve the changes, find the related operations, and you may remember there was a roughing and a floor finishing operation there. Let's delete that because it's no longer applicable, and let me rerun just for this feature the best practice operations and see if we can get something different. So now without the highly accurate surface finish at the floor, I'm expecting to get different operations. And it's finished. So let's find the operations for that feature. And here we are, and now it just requires a roughing operation. Right? And we're done. It doesn't require a floor finishing operation anymore. We quickly look at the rest of the views, then you will see this is the entire list of operations that we just generated in that single command. A few milling operations and mostly drilling operations. And if we look at the tools, although the geometry is not that complex, I quickly have a lot of tools because I have different diameter holes, different quality, different tap drill sizes. So those are the tools that were selected automatically. So hopefully that gives you a quick idea of what feature-based machining can do. As a next step, I would like to show you something similar, but now on a different process. As I mentioned previously, we can do this on milling drilling, but we can also do it on wire EDM. So if I look at this wire EDM setup, I actually have some geometry defined, but no operations, no tools. And I can do the same here. I can go to my feature navigator, do find features. Now I don't want to find everything. I just want to look at specific wire EDM features. And let's just do one specific type and find try and find those features. I find them. I don't need the coordinate system. So I have 3 different wire EDM features found. Let's try and see if we can run some operations for those. Now instead of doing mill drilling on this geometry, I actually want to use wire EDM knowledge, generating that, looking in the library, what are the best practices for doing wire EDM geometry like this, and looking at my operation navigator, expand L, I'm actually seeing 3 feature groups. They're all different. For each of the feature groups, we actually now created, hopefully you can see that, the boundaries that I need for my wire EDM operations, the boundaries. And if I generate the toolpaths, quickly done, you will see an internal trim operation with a single roughing pass and 3 finishing passes, something, whatever I want it to be, right? So we can generate that type of operations as well. maybe you're saying, and this is a quick glimpse ahead to the next sessions. Maybe you're saying, well, why did you do an internal trim? Why not do a no-core operation, right? Remove all that material. And I actually have my machining knowledge editor up, which we'll explain in the next session, where all this can be configured. And I see two operations here, two rules for my my wire EDM free shape feature type. One is internal trim, and the other is no core. And I see that the no core has a lower priority value, so it's an alternative that's not being used. If I would change that priority, save my best practice rules, and just undo my results here, so that I just have the features, and I was very quick, but no operations anymore. And let me just rerun the process with a small change in the machining knowledge editor. Running it again. Now, if everything works as I hope, I shouldn't see the internal trim operation anymore, but I should see an no-core operation. So let's see if that worked. Expand all. There we are. Generate. Maybe it's not a good idea to do it like this, but there's my no-core operation, right? So a simple small change to my rules, and I get different results. And obviously, we'll explain that in much more detail later in the next sessions, how you can configure the process that you get. The last thing I want to show you is how to have this work on neutral geometry that was not modeled in NX. Let's say maybe a step file. So I'm going to do that completely live. I'm going to open the step file. Need to switch, and I'm just taking from scratch a part which, if we look at the geometry, you will see it's just a body. There's nothing there. It's an imported geometry. Before we get started, let me make some visual changes, because it's very hard to work with it this way. So I'll change the object display. I'll change the color to smoke gray, and I'll change the transparency a little, so it's a little better to see what we're doing. I'm going to do a file new and change to manufacturing. So I'm making a manufacturing setup for this. And all I need to do is define my workpiece. I don't care about a blank or fixtures at the moment. Bear with me. And let's do feature recognition on a geometry like this. So bring up the Find Features dialog again. We've seen it before. I'm no longer interested in running wire EDM. I'm looking at the stepped features. Maybe I do a slot partial rectangular and no slots. It's okay. I don't have to do everything. Let's go find it. You will basically see it works fine on imported geometry as well. But there's a glitch, and we'll get to that in a minute. Right? So I don't want to see the coordinate systems. You'll see a lot of holes, a lot of pockets, and again, I didn't recognize everything that I wanted to recognize, but you basically get the picture. But if I just take a few of those and do create feature process as we've done before, you will notice I am not going to use wire EDM mill drill. You will notice that I have no PMI, right? All the holes are just regular holes. There's no thread. There's no dimension tolerances, so there's no fit holes. Everything is just regular holes, And since we don't know anything more about the geometry than just its dimensions, we will pretty much just drill and mill everything without using any real finishing operations. Right? So going to my operation navigator and expanding everything, you'll see the holes. It's just drilling. Simple drilling, and so on and so forth. Right? It's good. It works. I can cut them, but it would be good if I can also use know a difference between some threaded holes and some fit holes. Now, obviously, I could go into NX modeling and now maybe model some threads, but I'll remove the operations again, and I'll remove the features. There's an alternative there. And the alternative is to look at, as an example, color coding. Color coding is something that's a standard in many industries, and colors are nicely retained when exchanging step. So let me show you a few face selections. Let's just change those to yellow faces. Object display. Make those faces yellow. And in Europe automotive industry, yellow holes are threaded holes. And let's select a few more holes, faces that is, and object display. I'll color those blue, and blue holes are fit holes. Right? Now let's run feature recognition again. This time, let me just check the setting, right, properly set. This time I'm going to add some additional magic that we'll explain in the next sessions that we call feature mapping. And using feature mapping, I can actually have some more criteria in place. I can say not just look at the geometry, but apply some other mechanisms. And you'll see in a second what the effect is. I'm now going to select just a few faces of the part. I'm not going to do the recognition for the entire part, just selecting some faces, and I want feature recognition to find only the geometry related to the faces that I selected. And what you'll see now is that surprisingly those two features are now found as threaded holes, and that's because they were yellow, and I had configured my my mapping rules to say yellow holes are threaded holes. So if I look at the attributes there, it's actually an M8 with a 1.25 pitch. And if we select one of the blue features, we'll actually see a diameter with a diameter tolerance, right? It's again an H7. If I pick one of the other ones that's geometrically identical, you'll see a different tolerance. So the last thing I'm going to do is now run the create feature process one last time, and hopefully show you that with just some simple color coding and some mapping rules in place, I get different operations, even though the geometry is exactly the same. There we are. And let's switch, expand everything. So those were just drilled holes. But the other ones, the blue ones, were reamed because they're fit holes. Those two are just drilled holes. The other two with the yellow color are tapped, right? So that shows some of the power of feature-based machining. If we switch back, Derek, to the two summary slides, please.
Here comes your presentation back.
Thank you so much. So to wrap it up, Why are people using this? Why are they interested in feature-based machining? Because as I'm hoping you've seen from this demo, it can significantly reduce the time that people need to do NC programming. We don't expect people to do 100% automation. That can only apply to some specific parts, but usually if you can automate 80% of the work, that saves tremendous amount of time. It can increase your process quality because you will always get the same standard best practice results, and it will avoid people making mistakes on simple and repetitive work, and it will also improve standardization, not just on standard processes but also on standard tools. Many shops have tons and tons of tools, a lot of money invested in tools because all the NC programmers use their own special tools, and this will give you a possibility to standardize on your tool inventory and reduce cost that way. We think very compelling reasons why people could have a look or should have a look at this. To wrap it up, to summarize, this was Tech Tip session number 1, showing FBM from a user point of view. We'll have 2 more next week, Tuesday, and the week after. In the next session, I'll explain how you can use feature teaching and operation teaching to customize feature-based machining, so how you can add things to the software that we don't know about out of the box, so adding your types of geometry, adding your processes. And on the last session, I'll go into depth into this machining knowledge editor. That's really for the experts, not for the end users, but for the people that want to set this up in their company, that are responsible for providing the best practices for the NC programmers. And we'll go into depth of how that works, what you can do with it, and I'll demonstrate that in depth as well. So with that, thank you very much for attending, and I'll try and answer any questions if you have.
Thanks, Tom. That was a great introductory session, and I want to encourage everyone to join us for the next 2 webinars in the Feature-Based Machining series. As always, the conversation continues at our discussion forum, where we will post these questions and you can pursue any follow-up topics.